Hi everyone, so this video is going to present our machine learning project design page. The goal of the project is to apply machine learning techniques to perform time series forecasting. We extract the dataset of oil price index of the last 2 years from Yahoo API to perform a short-term prediction of the next 7 days. We focus on adjacent close price as it best describes the closing price for each day. The algorithm we implemented in this project are ARIMA model, which is a stats model that predicts financial movements by inspecting lag differences in the variables and the error of each lag, and LSTM model, which is an artificial recurrent neural network of deep learning. Despite the uncertainty of the time series itself, the key challenges that we have encountered when implementing the models can be concluded into 5 aspects: non-stationarity of the time series, structure plan of LSTM model on insufficient data values, long-term forecasting, order sequence of the time series, and time efficiency. To implement ARIMA model, we have to ensure that the time series is stationary, which implies that the mean variance and covariance of the series are invariant with respect to time. However, by evaluating the original data, we observed trends and seasonality. To remove trends and seasonality, we did log transformation, moving average smoothing, and first order differencing to make the time series stationary. We also implemented decay fuller test to check the stationarity of the time series. The explanation of diagonal checking is described in the report. Since the stock price indices are more meaningful when they are recent, we took only last 2 years of data to fit them into our models. In this situation, the amount of data is insufficient for LSTM model. To optimize the performance of LSTM model, we reduced the complexity of the model structure by taking only one LSTM cell. To find the optimal structure, we have compared different parameters, including number of LSTM layers, the size of memory states H, and the learning rate. In the report, we demonstrated the comparative evaluation in one graph. The ARIMA model is excellent for short-term prediction as it trains the indices from the start of the training set to predict the next value. To validate this, we have used out-of-time cross-validation to take a few steps back in time and forecast into the future, and compare the forecasting values against the true values. As for the natural behaviors on the time series data, the order sequence should be intact in order to forecast. We couldn't just randomly split the data into training set and test set. We used Panda series to store data and changed indexing on the series to plot on the diagram. Due to the non-linearity of activation functions, LSTM model takes much longer training time than ARIMA model. We have embedded GPU to implement LSTM model in PyTorch to make it more time efficient. We have also compared the training time on both models using Python building function time. So in conclusion, we have learned how to apply machine learning algorithms on time series forecasting, how to transform data from non-stationary to stationary, and how to interpret the diagnosis checking. By implementing LSTM model and ARIMA model, we have developed deeper understandings of the features of both models and their pros and cons. And most importantly, we have also come to a conclusion that it's not so easy to make money. The model can never hold the exact truth. They are just approximation towards reality. Thanks for watching.